In the last video we talked about how to rewrite two fractions, again technically speaking two rational expressions, so that they have common denominators. Like for example, if we have a over b and c over d, you have a common denominator in b times d. I don't know why I wrote this with notes. I'm going to go ahead and write this out here. So if you have a over b and c over d, so if you have these two fractions, you have a common denominator in BD. Okay, let's clear that off. A little space there. So if you have a over b times and c over d, then you have a common denominator in b times d. So that means you can rewrite a over b as AD over BD. So let's put this. So A over B is the same thing as AD over BD, and C over D is the same thing as CB, or I'll put BC to put it in alphabetical order, over BD. But it meant to put, doesn't really matter, but I meant to put BD, not DB. So now we have, even though these two fractions are different, even though A over B, and C over D, these two fractions are different, we can rewrite them in an unsimplified form that have the same denominators. So I just multiply top and bottom of this by D, which does not change the value of the overall expression. And for this I multiply top and bottom by B, which again does not change the overall value of the expression. But it's not enough that they be just the common denominators. They need to be the lowest common denominators. Like for example, let's do one more step, one unnecessary step, just to demonstrate the point. So what if I multiply top and bottom of this by E? See, and then I do the same thing over here. So BCE over BDE. See, now we do have two fractions. Like let's just say we skipped this step and we just put in an extra e for no reason at all. We have two fractions. This is equal to this, and this is equal to this, and they do have the same denominators, but the e is completely unnecessary. We can get rid of it and still have the same denominator. So that's why we want to find what's called the lowest common denominator. So the lowest common denominator of two rational expressions is a common denominator of two rational expressions with a very important feature. For any given factor, it does not have more of that factor than either of the original two rational expressions. Now, in this case, for any given factor, it does not. This is not a lowest common denominator. This BDE is not a lowest common denominator because it has more e's than appear in any of the originals, because there is no e. So that means that this e is unnecessary. Basically, what we're doing is we're getting rid of all unnecessary terms. So I have some. Actually, before we even get to, I have another thing about some results that might clarify what the point is, but for now, one thing I want to do is go ahead and demonstrate another point about the lowest common denominator. So let's say, for example, we have our two fractions that we're dealing with are a over b, well, it's down here, a over b and c over b squared. So now we have an a over b and c over b squared. So a common denominator, see, we might be tempted, okay, just multiply both sides, top and bottom of this, by the denominator here. And then you'd get ab squared over b cubed. So a common denominator would be, just a common denominator would be b cubed. It's true that it would be a common denominator, but it will not be a lowest common denominator. Because to make these two things have the same denominator, all we would have to do, we don't even have to mess with this one. We just have to multiply top and bottom of this by b. So, and the reason why I say this is because it's probably very tempting in a lot of cases to just say, okay, whenever I have two fractions and I need to find the common denominator, I'll just multiply top and bottom of the left by the denominator of the right, and multiply the right by right, I mean the right expression separated by a comma like I have written here, and multiply the right one by the multiply the top and bottom of the right one by the denominator of the left one, and that will give you a common denominator, but it will not get you the lowest common denominator. In this case, the lowest common denominator will not be b cubed. It'll be, it'll be b squared. So, so all we need to do to this is multiply top and bottom of this a over b by b to get ab over b squared. And now we have two expressions that are equal to each other. Not equal to each other. They have equal denominators. Okay, so let's talk about some notable results from this fact, from what we're talking about here. And we'll get to some examples that will hopefully make this a little bit more clear. The lowest, I'm going to go ahead and delete these here so we can have the notable results with the same screen as this. So the lowest common denominator will have exactly as many factors as it occurs most in the original two expressions. So that means let's put oops, didn't mean to do that. Let's do something down here. So if we have x over x plus 1 squared over x plus 2 and x squared over x plus 1, the lowest common denominator will have exactly as many of each factor. See, we have two different factors here. We have x plus 1 and x plus 2. But a lowest common denominator will have as many of each factor as it occurs most of it. Okay, so let me put a divider here. LCD equals, I'm going to put it down here. So it has x, and it will have x plus 1 and x plus 2. Because the lowest common denominator, since it is a common denominator, will have each factor in the denominators. But the important thing is what's going to be the power here and the power here. So it will have exactly as many of each factors as it occurs most in the original expressions. So this x plus 1 in this one occurs exactly one time. But in this one, it occurs twice because it has this to the power of 2 here. So that means this part will have a power of 2. So the power of this will be the largest power that it has over here. So the x, whoops, yes, that's right. Okay, sorry, I thought I put it on the wrong one. So okay, yeah. At any rate, let's continue. Sorry about that. So the power that each factor has will be the largest power that it has over here for each of these. It occurs at most one time here. Let's change this a little bit. Let's change this to a different, this is a fundamentally different problem. Instead of x plus 1, it's x plus 1 cubed. Then that means this will change to a 3 because it occurs at most 3 times. Now let's change it to another different problem where it has x plus 1 squared. Well, it occurs twice here, it also occurs twice here. So that means the most it occurs is twice. So whichever number is largest is the amount it's going to have over here. Okay, so the main point of the lowest common denominators is that it will have no more factors than is absolutely necessary for the two rational expressions to have the same denominator. So let's get back to what this is, what the original problem of that was. It will have no more than 2x plus 1s, because we don't need any more than 2x plus 1s to get these to have the same denominator. That's the whole point of the lowest common denominator. That's why we do it. And another result is that the LCD of two rational expressions is unique, like the one that I deleted earlier. So let's erase this. Let's just clear off the whole thing. So remember, I had a over b and c over b squared. Well, there are a lot of common denominators for this. I mean, we could have a common denominator in b squared, we could have a denominator in b cubed, and we could have a common denominator in ab cubed. It just multiply top and bottom of this by ab squared, and multiply top and bottom of this by ab. But there is only one lowest common denominator. See, these two right here are unnecessarily complicated, because they have more factors than we need. But there is exactly one lowest common denominator, and that's b squared. So I know this is probably kind of a strange concept, but let's go on to an example. I think probably the best way to understand this is to by example, and by and if it helps, hopefully you'll be able to watch through this particular video again, and maybe if you watch it a few times. That's what I do with Sal Khan's videos, to say the truth. Sometimes I have to watch it 2 or 3 times before I understand it, but then I'm so glad that I have it in YouTube form so that I can rewind. And that's exactly why I do these videos, so that my students can rewind them and watch them again. Okay, so let's talk about this example. So we have x over x plus 1. This is pretty similar to the example I just gave, but it's not exactly the same. We want to find the lowest common denominator. I'm not doing anything with the lowest common denominator yet, but we want to find the lowest common denominator of these two rational expressions. So we have x over x plus 1 times x plus 2, and then x squared over x plus 1 times x plus 3. Okay, so if you wanted to do it the quick and easy, not easy way, if you want to do it the lazy way, that ends up being harder than you might expect it to be, to find just a common denominator, we'd multiply top and bottom of this by this denominator here, and multiply top and bottom of this by this denominator here. That's going to make things unnecessarily complicated, though, because we will have this x plus 1 occurring more than we need for it to. So if you want to find the lowest common denominator, I'm going to do it right here, we look for, at most, how many of each factors, how many does each factor appear. So I'm going to write out all of the individual factors that I see. So this has x plus 1 as a factor. And we also have x plus 2, that's another factor. And there's an x plus 1 here, but we already have x plus 1. And then there's an x plus 3 here, that's another factor, one that we don't have yet. Now the trick is, how many does each one occur? So we look for the greatest amount that it occurs in the original problems. So if we have, our LCD is x plus 1, so at most, how much does this x plus 1 occur in these two original problems? Well, we have it occurring once here and once here, so it occurs once here. At most, how much does x plus 2 occur? It occurs once here, no times here, and 1 is bigger than 0, so it occurs once here. If it occurs, so this x plus 3 occurs no times in this first one, but 1 time in the second one, so it occurs 1 time here. Now, let's change the problem. Fundamentally change the problem. We have, instead of this x plus 1, I'm going to make this x plus 1 quantity squared. So that means that this x plus 1, so I'm going to start this problem over just from scratch, just so that you can see this from the beginning. And just so that it looks completely different, I'll change this 3 to a 4. Doesn't really matter, but what the heck, I thought I'd do that. So so our LCD is going to have all of the individual factors that we see. So it's going to have an x plus 1. It's going to have an x plus 2. And there's an x plus 1 here, but we already have that listed. And it's going to have an x plus 4. So, what is the most that this x plus 1 appears? It appears twice. It appears twice here and one time here. 2 is greater than 1, so the power is going to be 2. If this were 3, no, let's change this second one here. So let's change this. Again, this is a fundamentally different problem. Let's say that this were 3. Like, if this were x plus 1 cubed, then you'd have the LCD would be x plus 1 cubed, because 3 is bigger than 2. You always pick the one that is biggest. Since this appears 3 times, you choose x plus 1 quantity cubed. Then it also has at most 1 x plus 2 and at most 1 x plus 4. Okay, that concludes this particular section. In the next section, we're going to be putting this into practice, and you'll also see that whenever we find the lowest common denominators of these rational expressions, they will not always be in a factored form already. See, every example that I've given you so far, this is already factored out. But what if this would have been multiplied? I mean, hopefully you'll never have to factor out an a quadrinomial. I guess, I don't know. So you'll never have to factor out in this class something to the power of 3, unless you can factor out the x. So at any rate, the point being, that was kind of a side note. The point that I'm making is that you sometimes have to factor out before you can find a common denominator. Alright, I will see you in the next video where we start to add and subtract these.